This video is going to focus on the derivatives of e to the x and natural log of x. Those are inverses of each other. You'll find that these rules are not very difficult, but when you have to start applying the chain rule and some of the other rules too along with it, it gets a little bit more difficult. So the easiest rule you'll study all year, the derivative of e to the x is e to the x. If you look at our two examples though, we are not just taking the derivative of e to the x, it's e to another function. And so for both of these examples we have to use the chain rule. First example, find the derivative of e to the 2x minus 1 power. So our rule says the derivative will be, let me rephrase that, let's just say that we're just going to say an equal symbol here because it's saying take the derivative of the function, so we're actually going to do that and write the derivative right there. Our rule says that it's going to equal itself, so e to the 2x minus 1 power, but because this power is not just x, because it's another function, we need to apply the chain rule. So what is the derivative of that inside function? What's the derivative of 2x minus 1? That derivative is the number 2. And so in the end, just to make sure we're all on the same page, the answer would be 2 times e to the 2x minus 1. Only e is being raised to that power. Example 3, find the derivative of e to the negative 3 over x. So again, our rule says, first of all, I might rewrite this one. It might be a little bit easier to follow along with the chain rule. We're trying to take the derivative of e raised to the negative 3x to the negative 1 power. It might be a little bit easier to work that chain rule with this version. So our rule says if we take the derivative, rewrite the original, so we'd have e to the negative 3x to the negative 1 power, and then we need to take the derivative of the inside function, or the derivative of the power, and apply it to the back. So we're going to go times, and the derivative of that inside function, we're going to bring the power of negative 1 down to the front, multiply by a negative 3, we're going to get a positive 3 from that, and then it's going to be x, the power goes down by 1, so x to the negative 2, whoops, that's a negative symbol there, there we go. And then we'll just clean it up a little bit. If we were to kind of put this all together, I'm going to bring the 3 and this part out to the front a little bit, so I would have, I'm going to have a 3 over, let's see here, how am I going to write this? We're going to have 3 over x squared times an e to the negative 3 over x power. That's just one way to write this, but that's how I'm going to put it. So there are our two answers, our intro into the derivative of e to the x, more complicated when you apply the chain rule. Okay, derivative of natural log of x is simply 1 over x. We're actually going to prove this a little bit. Prove the following derivative rule using implicit differentiation. To start out, we're going to be looking at the function y, whoops, get a pen here, y equals natural log of x. Lots of steps that we could follow here, just to get it kind of into an order that's going to work for us. All this is going to be legal, but we have a rule that says I can take this and put any power below these things. And so I'm going to choose e for a certain reason here. I'm going to say e to the y has to equal e to the natural log of x. And the reason I chose e is because the stuff on the right side now, e and natural log will cancel off, and I'm left with this. And now we're going to take the derivative. I couldn't take the derivative at the first part because we're assuming we don't know what that derivative of this would be. We're trying to prove that it's this. And so we're now going to take the derivative of something that's equivalent to it. Okay, so now we're going to take the derivatives. Just write a little note here that we derive at this point. And I would get, remember that the derivative of e to the x is e to the x, so the derivative of e to the y is e to the y. But if you think back, because it's involving a y, I need to put a dy dx after this piece. Derivative of x is just 1. Okay, my job is to solve for dy dx, so that means I'm going to divide by e to the y on both sides. So I get dy over dx equals 1 over e to the y. And you might think that you're stuck. We have solved for dy dx right now. And remember, we're trying to show that dy dx equals 1 over x. Well, remember this part way up here, e to the y equals x. That means that this denominator, the entire denominator, really equals x. And so in the end, our last step, dy dx equals 1 over x. So that's why that rule works that way. Again, the rule itself is not too bad. It's when you start applying the chain rule. So for both of these, pretty straightforward. If we understand the general rule, we're trying to find y prime if y equals natural log of 2x plus 2. So y prime is going to equal the derivative of natural log is 1 over x. So that's like my outside function. 2x plus 2 is the inside function. It's going to stay, instead of just writing an x in the denominator, we write that inside function. And then we need to multiply by the derivative. Thinking of the chain rule here, you have to multiply by the derivative of the inside function. So what is the derivative of 2x plus 2 going to be? It's going to be 2. So really I have 2 over 2x plus 2. You think through this, all three parts have a 2 in it, so I can kind of simplify this a little bit. I guess algebraically the best way to show that would be to factor a 2 out of both parts in the denominator. These are going to cancel out then. And in the end, I'm left with 1 over x plus 1. That would be the simplest answer for this one. Okay, next one, we are now looking at f of x equals natural log of tangent of x. Works basically the same way. F prime is going to equal 1 over x to start off, except our inside function is tangent of x. So instead of 1 over x, we have 1 over tangent of x. The derivative of the inside function, the derivative of tangent, is secant squared. So that completes the chain rule. Now, how do we simplify this? I mean, that's a fine answer. I could write it as secant squared over tangent of x, so we might be okay. But if we had to simplify this a little bit, let's do a little trig review here. Remember that tangent is really cotangent. 1 over tangent is really just cotangent. We still have times secant squared x. From there, we'll just write both of them in terms of sine and cosine. So cotangent is cosine over sine. And secant is 1 over cosine, so secant squared is 1 over cosine squared. And so what's going to happen here is all of that will cancel out one of those, and we're really left with 1 over sine x times cosine x. I am not saying that's the answer that you would have to get to, but that is one possibility. They're going to ask you to simplify all the way to that answer, so we have to be ready for it. Okay, we'll look at some more rules in the next video.